So let us look at the concept of power and energy. In the last videos, we have seen the concept of work and also various cases of work, that is a positive work, negative work and zero. So let's continue with the concept of power and energy. So the power is nothing but the rate of doing work. So that means rate means how fast a work is done. So the time comes into picture. For example, there are two people, A and B. A works fast, but B works slow. The same amount of work will be done quickly by A and the same amount of work will be done slowly by B. For example, lifting a cart. If I have to lift a carton box, so if I do it fast, then I would say my power is more. And then the person who lifts it slowly, we will say the power of that person is less. So the power is all about how quickly that we do work. If the power is more, then the work can be done faster. If the power is less, then the work will be done slower. So the formula for the power is equal to work done divided by time. That is the rate. Rate means time divided by time. How fast that we do it. This work, how fast I am doing this work. So work divided by time. We already know from the definition of the work, it is work is equal to force multiplied by distance. And then substitute work is equal to F into S. So work is equal to F into S divided by T. But if you have observed that its distance divided by time is nothing but the velocity. So we will substitute velocity here in place of S by T. That is equal to F is work done is equal to power is equal to force multiplied by velocity. So the power has two formula. Either in one case, if the work done is given, the way to calculate the power is you substitute work done divided by time. Sometimes work done is not given and directly the velocity will be given. So in that case, you need to say you write force multiplied by velocity. For example, a force is applied on a car. If the force is applied on a car, then car moves with this velocity. Then what is the work done? Then you need to say work done is equal to force multiplied by velocity. And sometimes it is said directly work done is given. If the work done on a body is these many joules, then what is the power? Then the power is equal to work done divided by time. So the power has two formula. It is important to remember both of them. Good if both force and the velocity are in the same direction. But we also said that the work done can also be written as F into S into cos theta when there is an angle between F and S. So F into S into cos theta, if we substitute that, then it will become again S by T, we can write it as velocity. So F V multiplied by cos theta. That is, if the force and the velocity are in different direction or at an angle. So if this is my force and this is my velocity, then it is F V cos theta is the formula for power. Or if my force and the velocity, both of them are in the same direction, then the formula for power is equal to F multiplied by V. As you understand that the power is a scalar quantity, it is not a vector quantity. We never say that power is in this direction, power is in that direction, no. So we cannot give any direction to the power, so power is a scalar quantity. What is the SI unit of power? Very important, it is watt. What are the other units of power? You have kilowatts, megawatts, gigawatts and horsepower. These are the other units. Kilowatts means, kilo means 1000 watts. Mega means 10 power 6, that is 10 power 6 watts. Giga means 10 power 9, that is 10 power 9 watts. And horsepower. So what is the relationship between horsepower and watt? 1 horsepower is equal to 746 watts. If you know that the motors that are there in your home will be rated according to the horsepower. So the motor will be told that it has 1 horsepower, half horsepower. So that is the unit of the power. So that means that much quickly that it can do the work or lift the water from the earth. So 1 horsepower is equal to 746. This conversion factor is very important to memorize because this is an important question in your board exam. Let's look at the concept of energy. What is energy? Energy is the capacity to do work. If I have the capacity to do work, then I say that this body has an energy. So energy is to do with only the capacity. So if a body has a capacity to do work, then we will say that the body has energy. And then is it a scalar quantity or a vector quantity? Of course, it is a scalar quantity. We cannot say that the energy in the north, energy in the south direction. No, we will never say that. So energy is a scalar quantity. What is the SI unit of energy? It is joules, and CGS unit is erg. If you have noticed, the work also has same units. Work also has SI unit as joule and CGS unit as erg. So both of them have the same units. So please remember that, because both of them are a similar quantity. As we go ahead, we will discuss about that. What are the other units of energy? Calorie, EV, watt-hour. So very important to know, because these conversion factors are very important. You will definitely get 1 marker from here. So calorie, EV and watt-hour are the different units of work. What is calorie? 1 calorie is equal to 4.2 joules. Very important to remember. 1 EV, where do we use electron volt? EV means electron volts. Where do we use electron volts? This is the work done in electrons, protons, neutrons, these small particles, subatomic particles. The work done there is very small. So we cannot use a big quantity like calorie. There, if you see, the work is equal to 1 electron volt is equal to 1.6 into 10 power minus 19 joules. That is minus 19 means so small number. So for small work done, we cannot use this big unit. So we need to define another smaller unit, that is called 1 electron volt. What is the relationship between 1 electron volt and joule? 1 electron volt is equal to 1.6 into 10 power minus 19 joules. Okay, what is watt hour? Watt hour is equal to 3600 joules. So the watt hour is a unit that is used to measure the electrical energy that is spent. So that is a big unit. Electrical energy spent is big unit. So that is why we have defined 1 watt hour as 3600 joules. So it will be easy to measure electrical energy. So these are the conversion factors that needs to be remembered. Very important, definitely.